This screencast is for anyone that is unable to join me during K-9 office hours on Friday, September 4th, where I'm going over how to find the area of some figures. In these first three problems, we're asked to find the area of the shaded region. So let's start with figure A. So far, what we've learned is that we can decompose figures into smaller shapes without changing the area of the original figure. And since we don't have a formula for figure A, which is like a staircase, we can decompose it into rectangles. So for example, I could draw a line right there and draw a line right there to make three rectangles. This left rectangle is 2 units by 1, 2, 3, 4, 5 units, and 2 times 5 is 10. This middle rectangle is 2 units by 4 units, and 2 times 4 is 8. And this short rectangle is 2 units by 2 units. 2 times 2 is 4. 10 plus 8 is 18, and 18 plus 4 is 22. So the area of figure A is 22 square units. All right, figure B. The way that I would do figure B is to first find the area of the large square and then subtract out the areas of the two unshaded squares. The large square is 1, 2, 3, 4, 5, 6 units by 1, 2, 3, 4, 5, 6 units. 6 times 6 is 36. And then the squares inside are both the same shape and size, so they have the same area. So if we find the area of one, we can find the area of both. So this square is 2 units by 2 units, which is 4. If this square is 4 units, then this square is also 4 units. 4 plus 4 is 8. And so we want to subtract out the area of the unshaded squares from the large square, and that will leave us with the area of the shaded portion. 36 minus 8 is 28. So the area of the shaded portion of figure B is 28 square units. And for figure C, what we can do is decompose this into a rectangle and a triangle. The rectangle is 1, 2, 3, 4, 5, 6 units by 1, 2 units. 2 times 6 is 12. And then for the two triangles on top, I'm going to decompose them further into two triangles right here. I notice that both triangles are the same shape and size, so I know they have the exact same area. So if I find the area of one of the triangles, then I'll know the area of both of the triangles. So for the top right triangle there, I'm going to enclose it in a rectangle. I'm going to find the area of the rectangle because I see that the area of the shaded triangle inside the rectangle is exactly half the area of the rectangle. So if the rectangle is 1, 2, 3 units by 1, 2 units, the area of the rectangle is 6 square units. That means the area of the triangle inside is 3 square units, half the rectangle, which means this triangle is also 3 square units. So we have 12 units for the rectangle plus 3 units each for the two triangles. 12 plus 3 is 15. 15 plus 3 is 18. So the area of the shaded region is 18 square units. All right, for this figure, I can decompose this kind of L-shaped figure into two rectangles. If I slice it right there, you could also slice it going down right there and to make a square-ish figure here and then a big tall rectangle here. Either strategy works. I'm just doing the one that I happen to see first. That's the cool thing, is there's usually more than one way to arrive at the correct answer in a math problem. So we've got the top square is a 2 by 2 square. 2 times 2 is 4. Its area is 4. 4. There we go. All right, now for the bottom rectangle, the bottom side is 6. We have to figure out what this length is, but that's not too difficult to figure out. If this side of the small square is 2, then that means that side is also 2. And if this entire side is 6 centimeters, 6 centimeters minus that 2 centimeter chunk leaves us with a 4 centimeter chunk. 6 times 4 is 24. And then 24 for the small rectangle plus 4 for the large rectangle means the total area of that figure is 28 square units. Okay, for this figure, the shaded portion has a white region, an unshaded region inside of it, so we need to subtract out the area of that region. The large rectangle is an 8 by 5 rectangle. 8 times 5 is 40. The unshaded rectangle inside is 2 centimeters by 3 centimeters. 2 times 3 is 6. So if 40 is the space inside this entire rectangle, and we want to take out that unshaded portion, 40 minus 6 is 34. So the shaded portion of this figure is 34 square centimeters. And then finally for this one, this is a triangle. We don't yet know the formula for the area of a triangle, but what we can do is we can decompose this triangle into two smaller triangles, just like that. I notice that both triangles are the exact same shape and size, and so if I find the area of one of the triangles, then I know the area of both of the triangles. Now I'm going to enclose one of these triangles in a rectangle, just like that. And I notice that the enclosed triangle is exactly half the size of that rectangle. So when I find the area of that rectangle, I can simply cut that amount in half, and that will give me the area of that triangle. The rectangle is 8 centimeters by 5 centimeters. 8 times 5 is 40. Half of that is 20. So the area of that triangle right there is 20 square centimeters, which means this triangle is also 20 square centimeters. And so that means the entire area of the entire shaded region is 20 plus 20, which is 40 square centimeters. So to recap, what we have always done is we have tried to decompose into decompose into rectangles because we have formulas for rectangles. Or if we have to deal with triangles, we have enclosed the triangle in a rectangle, found the area of the rectangle, and then cut that in half because the triangle is always half the area of the rectangle that encloses it. And that strategy worked for all of these. Hope you found this helpful.